Four discharge capacitors C1, C2, C3 and C4 are connected as shown in the figure. A potential difference is applied between the point X and Y. Yes, a potential is given and the system is allowed to reach the steady state. Okay, what should be the relation between the capacitances of the capacitor be so that the potential difference between the points X and Y is 0? Let's find out the potential at X and Y. Here X and Y, then we try to solve them. Okay, so at first we have to know that if two capacitors are in series, their charge be same. Why it's so? For series connection, the charging current flowing through the capacitor is same because there is only one path. Okay, that's why each capacitor will store the same amount of electric charge regardless of their capacitances. Okay, here is C1 and C2, but their charges remain same. Now a potential difference is applied. Let's at point X its potential 0 and here 0 at point 1 Y, so their potential difference be V. Now if we take that potential at X point is Vx, then the charge stored in the capacitor C1 becomes, as we know, Q equals to CV. C1 that into potential difference V minus Vx, that is equal to at the charge stored in capacitor C2, that becomes C2 that into potential difference, that is Vx. From there we get Vx. If we divide it by Vx, V by Vx minus 1 equals to C2 by C1, and V by Vx becomes C2 plus C1 that divided by C1. Okay, and Vx be what? C1 by C1 plus C2 that into V. Okay, so similarly we can find out that Vy be what? Vy be C4 divided by C4 plus C3 that into V, and given there for what relation? The potential differences between the point X and Y is 0. It means their potential becomes same. So if we equate them, Vx equals to Vy, it's become C1 by C1 plus C2 that equals to C4 by C4 plus C3. Okay, from there if we invert them, then it becomes C2 by C1 that plus 1 that equals to C3 by C4 plus 1. 1 get cancelled, it becomes C2 by C1 equals to C3 by C4. From there we can easily get C1 by C4 equals to C2 by C3. So our option A is correct. Okay.